Swayam Prabha. Digital India. Educated India.
Welcome to this course on transition metal organometallics in catalysis and biology. In continuation with our earlier discussion on various type of olefin metathesis reaction, we have been talking about ring opening metathesis. In particular, we have been talking about two variations of ring opening metathesis. One is just simple ring opening metathesis, the other is ring opening cross metathesis reactions. Now, in this discussion, it is important to note that these ring opening metathesis reactions are favorable for substrates which are under strain, like they have physical ring strain, which is the driving force for carrying out these ring opening metathesis reactions. So, today we are going to look at various examples of both types ring opening metathesis as well as ring opening cross metathesis reactions, and see how they have been used for synthesizing a variety of novel structures which are of importance commercially as well as from biological point of view. So, with this let us move on to various examples of ring opening metathesis reactions that we would be discussing in today's lecture. Or ROCM, this is popularly called, and a nice example is given by the reaction as shown. This is called oxanorbornene. The reaction of this with vinyl acetate gives this 5-membered cyclic compound which is a major product along with the other product which is OSC. Now, this reaction can be understood in the context of the transition state that may arise from binding of O acetate in one way resulting in the formation of this product, or the same can be also understood by the reaction with the substrate in opposite way, which will give the other product. And now this will lead to formation of two different products, of which the major product is the one which is shown over here. And as seen that here we see that the ring strain of oxanorbornene is the driving force for carrying out these cross metathesis ring opening cross metathesis reaction. Now, as we had discussed earlier that these metathesis reactions are often thermoneutral reactions in the by the fact that the energy required for breaking a double bond is also almost equal to energy required in the formation of double bond. So, there is no enthalpic gain as such from in metathesis reactions. However, there are other factors like the ring strain or elimination of a gaseous ethylene molecule which is formed as a product, which sort of leads to the formation of these ring opening cross metathesis products. Look at another interesting reaction for ROCM, ring opening cross metathesis, another interesting example. This is a cyclopropene ketal that reacts with and subsequent hydrolysis give these product. Now, this is a interesting molecule this cyclopropene ketal. If seen closely, this is nothing but derived from the protection or protection of the carbonyl group to give this ketal moiety, and this is cyclopropene ketone. Now, this in this structure is not very stable, it has a more stable structure which is in its deuterionic form. Now, this is cyclopropyl cation, and now this is conjugated aromatic compound. So, this cyclopropane a propene cation is an interesting compound which is sort of derived from cyclopropane ketone and which is stabilized in its zwitterionic resonance form. Now, as far as this ROCM cross metathesis reaction goes, then one can sort of envision the reaction between the two olefinic substrates leading to the formation of the desired compound. Proceeding further, we are going to take a look at another example of ring opening cross metathesis reaction. And in this case the substrate is also a strained compound, bicyclic compound with considerable ring strain. That reacts with this olefin to give this compound so it becomes a 5-membered cyclic compound as is shown over here, and if one looks at how the reaction goes, plus (11), and then if the orientation of the two olefins are such, then this goes through the 4-membered cyclic intermediate transition state to give the desired product, which would have one moiety of this and the other moiety this CH2 group arising on this end and the rest of the fragment being over here. And here also we see that this is a highly strained substrate where there is a 5-membered as well as a 4-membered ring, and of these the 4-membered ring, which is under severe strain, opens up to give the corresponding ring opening cross metathesis product, and this compound is called heptane, bicyclo 320 heptane. Now, these have gone beyond achiral substrates to even the chiral forms of these has been reported, and in this case the catalyst obviously the metathesis catalyst used for the study is a chiral compound. So, we are going to take a look at several of the chiral examples that have been reported for ring opening cross metathesis reaction. Asymmetric ROCM or ring opening cross metathesis reaction, and the substrate for this is called mesonorbornene, the structure of which is shown here. Mesonorbornene in reaction with allyl borane in this cross metathesis reaction, the catalyst is an asymmetric or chiral complex as is shown here. There is a T butyl group and this is highly sterically demanding with another T butyl group, both bound to molybdenum, and this is a molybdenum imido carbene compound with phenyl and 2-methyl R equals adamantyl to give the compound which is shown over here. And and the transition state can be envisioned from the reaction of this allyl borane in a conformation similar to this. So, that this is corresponding to the vinyl substituent over here, and this fragment is corresponding to the boronic ester substrate over here, and needless to mention that this also has considerable ring strain that is so characteristic of this ring opening cross metathesis reaction, and has been successfully utilized for preparing this asymmetric chiral compound using asymmetric ring opening cross metathesis reaction. We are going to look at another interesting example of asymmetric ring opening cross metathesis reaction. And here also another bicyclic steric substrate is used, which is oxabicyclo 3,2,1 octane. That reaction with styrene, again using a chiral catalyst, which I will draw over here. Ruthenium and in heterocyclic carbene with a mesetyl moiety on one end, and bi binol with the oxygen bound to ruthenium as is shown over here to give the corresponding product and the catalyst used is a chiral ruthenium carbene complex. Here too we see that a highly strained bicyclic octane ring has been used using a chiral sterically demanding chiral ruthenium carbene complex to give the product. Proceeding further, we are going to take a look at another example of ROCM ring opening cross metathesis, in which this reaction has been attempted 2 times. First one is a intermolecular cross metathesis and the second one is a intramolecular cross metathesis. This is an interesting reaction. So, here too one starts with an strained oxanorbornene which is highly strained ring that reacts with butadiene to give the corresponding ring opened cross metathesis product. This is a protecting group. So, one can see that this is intermolecular ROCM and that happens from the reaction of 2 substrates as is shown here. Giving to the desired product in which the fragment comes from the reaction of this and the other fragment comes from the reaction of this. So, the reaction does not stop here, it further undergoes intramolecular ROCM, in which these two olefin reacts in an intramolecular fashion to give the product as is shown here. And this is a ring expansion that happens over here. So, this is a interesting example where we saw two types of ring opening cross metathesis happening. The first one is intramolecular ROCM followed by intermolecular ROCM followed by intramolecular ROCM, again resulting in a bicyclic ring. However, this is in much more expanded form than it is over here, and hence this release of stirring ring strain on going from here to here occurs using this nice example of intermolecular and intramolecular ROCM. Ring opening cross metathesis reaction. So, with this I come to end of today's discussion, where we have seen various example of ring opening cross metathesis reaction starting from their achiral variant to their asymmetric variant, and what we had observed that in all of these cases of ring opening metathesis reactions, that the substrates are bicyclic compounds, mostly bicyclic compounds with substantial ring strain, which provides the impetus for the reaction. We have also looked into the chiral versions in which sterically demanding chiral catalysts have been used mainly with bienol fragments bound to the metal, and they also successfully carry out these ring opening cross metathesis in the asymmetric fashion. We have also looked at a very nice example in the last slide, in which oxo-norbornene compound undergoes reaction with butadiene first in a intermolecular ROCM fashion, followed by intramolecular ROCM fashion, resulting in the ring expansion to give another bicyclic compound. So, with this I come to the conclusion of today's lecture. We are going to take up this more on this ring opening reactions, particularly with regard to ring opening metathesis polymerization or ROMP, as we start in the next lecture. Till then, goodbye and thank you.